Hello and welcome. Today we'll be going through the OptiAssist for Abaqus. This is the tutorial 5, the ply shape optimization considering ply symmetry. For this example, we'll demonstrate the principle of linking opposing candidate plies located either side of a mirror plane. In this example, it will be the left hand side and the right hand side. Examples of 30-degree ply to then its minus 30-degree ply. This demonstrates symmetry, which we will prove with a subsequent CSV file made from the optimization. As you can see here, I have already loaded up the initial tutorial 5 ODB file. Here you can see the initial displacement at the base of the model at about 0.235 mil. To begin this, we will go to OptiAssist for Abaqus and click Load Abaqus Input File, where we will find the .imp file. We'll click Open. When that has loaded, the first thing we are going to do is create a new thickness set data, whereby we will name it UD plies or unidirectional plies, the minimum being 0 and the maximum being 10. We will then sort the plies by material, and we'll click on all the plies that reference the UD fiber material. Click Assign Thickness Set, and then we will create a new ply pattern subdivision set. So under that we'll click New, and we'll also call this one UD plies. For this we will add a symmetry of MZX, so mirroring about the XZ plane, with a defined grid of 30 by 30 by 30. We'll click OK, and again with all the UD fiber materials referenced, we'll click Assign Subdivision. We'll click Next. Under ply linking, for the symmetry to be applied, we will use ply linking. To do this, we will select the left hand side or the right hand side of one of the plies, in this case the 30-degree, and then find its opposite, so in this case the minus 30-degree. Once you have done that, we'll click Add Symmetry, and repeat this for the other two plies listed. Once you have done that, we'll go Next, and for the goal, we'll use a drop down to change it to maximize stiffness, the target mass of 2.2 E minus 3, or 2.2 kilograms. Click Next. No further constraints are required except from the goal tab that was defined earlier. So we'll click Next. And once you are happy with the solution type setup, we'll click Submit. Once your optimization has finished running, if we go back to our Abaqus CAE and load up the new tutorial 5 OPT file, you'll be able to see your updated model. Here I'm taking a look at the total thickness created from the run. From here we can then change the results and step frame to show the number of plies, to show the left hand side and the right hand side in terms of the symmetry. To take this one step further, if we go over to the Excel file created from the optimization, the plyFactMap0.csv, we can see graphically, if I take a small sample of the data created from the optimization, it shows that the left hand side and the right hand side, the negative 30-degree to the 30-degree, has shown full symmetry throughout the optimization. This concludes the tutorial.